This morning we have a special guest. Noel Schulz is a co-PI on the project, and she's going to talk to us about grid and grid security. Is that it? Grid and power security.
I'm going to talk about power systems, and then Tim will talk more about security. So,
yeah. Tim is her son, and which Nunnally is her father. And I also want to mention that Noel is our first lady. So her husband is the president of WSU, Schulz. And it's a delight to have her today and as a colleague as well on this project. So she and I and Asfa and Shola Adeshopi, who will be joining us as well, have kind of spearheaded the project. Invited to my various institutions, and we've had a great journey doing this. So with no further ado, I'll let you go ahead.
Great.
And share anything else about yourself that you'd like.
Okay, I'm going to share a little bit about my background. So good morning and happy Tuesday, even though it feels like a Monday in a lot of ways. As Bernie said, I'm Noel Schulz, and I'm a faculty member in Power Systems. And I'm going to talk a little bit, I'm going to start off and talk for a little bit about kind of what's the big deal about power systems and cybersecurity? Why do we hear so much about it now? And then I'm going to turn it over to the cybersecurity expert in the family, Tim Schulz, who works for Skype and has also worked at Sendia, National Labs, and MITRE. And he'll talk to you a little bit and go through some more applied cybersecurity. But one of the important things as we look at cybersecurity is understanding the domains in which the cybersecurity is being used. And that's what I want to give you kind of everything you need to know about power systems in 30 minutes. Probably not, but at least start. And I'm going to give you also some resources that might be helpful if you want to learn more about cybersecurity and power systems. So I'm going to talk a little bit about my background and how I got to here, just because I think it's important for you to know that professors are people too. I have a sign in my office that says engineers build families too. Then I'm going to talk about kind of some power system terminology that we hear a lot. Then talk about the intersection between about smart distribution power systems, where we're seeing a lot of different needs related in the cyberspace because of the diversity of people involved. And then industrial control systems and cybersecurity. And then I'll turn it over to Tim to talk some more about cybersecurity. So first off, this is my family. These are actually my mom and dad, and my dad's on. My dad was electrical engineering professor at Virginia Tech. My mom was elementary school teacher, so I kind of come to engineering education from that angle. And then this is our family. My husband's a chemical engineer by practice, but does more people engineering as president right now. And then Tim, you're going to meet today. He and his wife Trisha are both cybersecurity experts and our family. And then Andrew's a PhD student in mechanical engineering. So we're kind of a computer science engineering geeky family that you see there. A little bit about how I got here. I've really had an opportunity to be all over the United States. I got my bachelor's and master's in electrical engineering at Virginia Tech. And I got my PhD in electrical engineering at University of Minnesota. And there I actually got a minor in computer science, which really got me connected to artificial intelligence, some of the different aspects of computer science that I really hadn't gotten in my undergrad and master's. I've had a chance to teach at a bunch of different universities: Virginia Tech, University of North Dakota, Michigan Tech, 200 to 300 inches of snow a winter. So don't miss those winters. Mississippi State, and then Kansas State for 7 years before coming 6 years ago to Washington State University. So I've had a chance to see a lot of the different power grids across the country and work with utilities in those spaces. My research areas, I work in the area of distributed energy resources, looking at how do we integrate them into the power grid, and we'll talk more about that. And looking at storage, electric vehicles, looking at renewables, intelligent system applications, as we look at AI, machine learning, all those techniques, and looking at that data analytics. A lot of my early career research was on storm management and outage management, and how do we get power grids back up quicker. And then looking at meters. And then rural electrification is one of my real interests. And actually, on a DOE project we have, we're electrifying a village in India, which is kind of a neat project. And I can talk about that at another time. And then shipboard power systems. So that's a little bit about my background. In 2012 and 2013, I had an opportunity to be president of the IEEE Power and Energy Society, which, as many of you probably know, IEEE is actually the largest professional organization worldwide. And the PES is the second society within that. Computer Society is the first. And I had a chance to travel all over the world and see so many different aspects of the power grid and meet professionals. And two of my initiatives, one was women in power, women in engineering, and something I have a passion for. The other one was really looking at a pipeline, and it's kind of small here, but how do we as a professional society continue to develop? Once you graduate, the learning doesn't stop. You still have to continue to learn. Those of you that are masters and PhDs show that. Those of us that are faculty are still learning that you continue. And so a professional organization, one of the things we want to do is make sure we're helping mid-career people as things change. And I use an example. My dad is an electrical engineer, and in his undergraduate work, he studied tubes. He didn't study transistors that we now use in VLSI till master's and PhD work. So if he had stopped learning at it as an undergrad, he would have been out of date. And for us, information is so much faster. So the reason I bring this up today is really, that's when I really started hearing more and more about over 10 years ago about cybersecurity and power systems. And we started seeing that as more as a topic on how do we integrate computer science into our power systems aspects. So what I want to do now is kind of talk about a couple topics, words that you heard, buzzwords you may have heard over time. Smart grids, microgrids, power grid security, resilience. We hear a lot of these words, and a lot of them relate to power system operations, and cybersecurity is part of that. So what are smart grids? Okay, so we'll have a little bit of, so I can stop talking for a little bit, we'll have a little bit of audience participation. What do you think a smart grid is, rather, besides just a grid that's smart? What do you think? Anybody? Go ahead.
They make fault discovery and repair incredibly easy, however, increase the attack surface of these systems.
Okay, so basically a smart grid is something that can identify where there's a fault, then try to fix the system and restore parts of it, I think is what you're saying. But that gives, because there's a lot of interfaces, that gives some opportunity for cyber attacks. Great. Anything else on smart grids?
I assume that like smart meters that are for measuring how much power use is going on in various parts of it, it's also going to be incorporated. So I guess abstracted smart grid is a power grid that has various electronic components that are dealing with some sort of computer check deal. They're providing some sort of information.
Yeah, great. So one of the things with the smart grid, and we'll talk about this, is we now have all this data about it. We have smart meters, every house that might be going as much as every 5 seconds. We have what we call phaser measurement units, and we'll see a picture of those that help tell us the status. It's kind of like the pulse of the grid at any one time. So we now have all these points that are out there. And then what do we do with those points? We input them into a control system and we do something with them. And we'll talk about the things, which means in a cybersecurity space, if someone goes and plays with those or disconnects them, then I can have an issue that I think I'm making a decision and I don't really have the data I think I have. Okay, so I'm going to go back, and how many of you were born after 2003? 2003 or later? Okay. Most of you, okay, a couple of you. So one of the things, so this, for those of us that are faculty, we remember 2003, but in 2003, there was this huge blackout on the East Coast and a part of Canada, and 50 million people in the US and Canada were in the blackout, okay? There were $6 billion in costs. And there was this big study that went and looked at why did we have this blackout? Okay, why did we have it? And it actually took them, one of the interesting things with this report, it took them 60 days to synchronize the times for the different utilities to be able to tell what happened first. So think about that, 60 days to figure out if A or B happened, right? We have our cell phones, we know exactly what second our pictures were taken. We have a lot of information now, but in 2003, none of that was coordinated. And there's a report here if you want to learn more about that. But basically, there were a bunch of recommendations that came out of that report. And so, so why are all the changes in the power grid, electric power grid in the early 2000s? Why was this, what was happening that caused this? One thing was the big advancement in computational capabilities and speeds, right? If you look at a lot of sparse matrix calculations in math and computer science, they are because power grid people tried to figure out ways to make shortcuts to invert matrices in math so they can do a lot of different contingencies. But the computers sped up so we could do power flows, we could do lots of what ifs. So that gave us lots of capabilities. Monitoring and sensors. We saw grid, we saw smart meters, we saw all these sensors now on lots of parts of the grid, not just the large transmission system and power plants. Power electronics and interfaces. We now, and when we use alternative energy such as solar and wind, we can't plug it directly into the grid. We have to interface that with power electronics. And that created more control schemes than what we're doing. And so the blackout of all those things were happening. And then the blackout happened. And we said, well, we've got to look at this at a whole across the board. And if you look at all four of those, they have cybersecurity implications, computational capabilities and speeds, monitoring and sensors, the power electronics and interfaces that are connected to the grid now, and then alternative energy, because now it's not, one person doesn't own the whole grid. There are lots of different groups, which means lots of different access points. So in 2007, Congress, and if you can't sleep, you can always go to this website and read this, but it came up with what we started to call the smart grid. Now, the grid was not dumb before 2003. It was not coordinated. It was kind of hit and miss. It was every utility was a little bit different, but basically the word smart grid really started to come out and be used as talking about how do we, a lot of these different aspects. And the big one, when you look at the Energy Independence and Security Act of 2007, was these 10 different parts of the grid. And I can talk about all 10 of those, but today we're going to focus on that first one. Increased use of digital information and controls technology to improve reliability, security, and efficiency of the grid. Okay, so basically we said we need to work together. We need to coordinate that information and we need to get more and more information. You can see there's a lot of other things about energy efficiency, about hybrids and storage, lots of other things in that. And the PowerPoint will be available if you want to go through all that. And if you're interested, let me know and we can talk more about the other topics. So what really happened with that increase? And with that increase in the use of digital information and technology, we now have all these different computer systems. And this is kind of an alphabet soup that talks about GIS, which is the geographical information, SCADA, supervisory control and data acquisition, distribution management, your customer information system, looking at your customers versus your power grid. And you've got communications in here. And you can see there's as we add solar, wind, electric vehicles, there's all this information network, which is communications, computational, as well as the power grid, right? That's in there, that's working together. Here's another example of a SIP, what we call a NERC, which is the North American Electric Reliability Corporation, actually has these cybersecurity related requirements. And you can see SIP is critical infrastructure protection. And then this just shows you a lot of different topics, and you can look up NERC SIP to learn more. And it's an important part of what we talk about with cybersecurity and the power grid. So look at the increase in data. So in 2011, this is a picture of different phaser measurement units. And a phaser measurement unit is unique because not only does it have a magnitude, but it also has an angle on values, voltages and currents. So it's basically a heartbeat of the power grid. And this is where we were in 2011. You can see they're kind of scattered. And then that's where we were in 2017. And these can come every, the timing on these, depending on how much data you want, can be in milliseconds, and compared to SCADA, that's 4 seconds, and so you have a ton of data now. So that's great. You have a ton of information, but A, how do you use it? And B, how do you make sure it's accurate information and it hasn't been hacked somehow? Because you're using this to make control decisions. So what is power system resilience? You'll hear a lot, we've heard a lot about power system resilience, right? We've heard a lot about resilience over the last 2 years with COVID, but when we talk about power system resilience, what is that? So if we go and look at 2020 and we talk about resilience, typically when we talk about resilience, we're talking about how do we respond to major issues, major challenges to the system. In 2020, we had, you can see all the hurricane and tropical storms that came in to different parts of the Atlantic. We also had wildfires. Australia had wildfires that burn up parts of the grid. This is a big issue in the Pacific Northwest. Fortunately, we've had a wet spring, so we haven't started on that yet, but it's a big issue is that. Water, there's either too much water or not enough water. And how does that impact the grid? Well, that impacts related to fires, but also particularly in Pacific Northwest, and Canada, we use a lot of hydro for our power bases. And so a couple of things, when you don't have much rain, you don't have the water. And then the other challenge is, as we've seen climate change and temperatures warm up, instead of becoming snow that stays in the mountains and then melts in July and August and provides water, it goes through the dams in June, which means we don't have, that snow is the ultimate battery when you think about hydropower. Okay, move on now to 2021. And there's a report that came out in 2021 that was done by the National Academies of Science and Engineering and Medicine, a group, and a WSU professor, Dr. Anjan Bose, was one of 15 experts across the US that helped write this. And this is a really great resource. We're going to talk about it a little bit more in a minute. And so that came out in February and really talked about what is the future of the grid? What are the challenges we need to be talking about? What are the things that we need to be working on with our future grid? And one of the need number 2 was basically reliable and resilient. And in 2021, Texas had some major issues related to temperatures and how equipment operated. And one of the interesting things is the power grid is really at the intersection of electricity, gas, coal, natural gas, a lot of different systems. We also had in the summer, in July, we had some rolling blackouts in the Spokane area that were caused because of some equipment failures and things on the grid. So we're trying to recover. So what is resilience? So resilience, and I like this curve because it's an engineering way of talking about resilience, right? So if you're, for the power grid, you're at some state, right? And one of the things you can do is you can prepare ahead of time, right? To try to be able to respond faster to an event. So And so you're at this state, some event happens, and it causes you to go to a degraded state. And then what you want to do, then at some point you recover. You may not recover all the way, you maybe go to partially, and then you are at that state for a while, and then you recover back, okay? And what we're trying to do with resilience is we're trying to minimize this time in here. We're trying to be able to respond. And there are things we can do over here to make the grid ready to deal with that. And then there are things we can do, and then we may come to an intermediate state, and then we can go all the way back to where the recovery, where we have. Now, if you have a hurricane come through and take out a bunch of the power grid, there's only so much you can do in some of these cases, right? Some of it's infrastructure, you've got to rebuild it and do that. But this is a graph that defines what resilience is, if we think about it. And so this is something you can go back to if you want to think about resilience. So let's think about the intersection of the power grid and cybersecurity and some recent thoughts. And I mentioned this report, and I know you all can't read this, but in chapter 6, it talks about a secure and resilient power system. And in that is the evolution of the grid and cybersecurity threats and challenges. And there's a lot of great information in here for you. And I'll set this link is you can download the whole file. You can download just this chapter for free from the National Academy site. And over there, it talks about some traditional approaches to grid security, and then what are some of the risks and things and problems that are there. So there's a lot of great information in here from experts on thinking about what's the grid of the future. And as you're thinking about career opportunities in the cyberspace, this is important. Power is very important in what we're doing and keeping it secure. This was the 5 out of that report. These were the 5 big topics that came out, and cybersecurity is a part of all of these. You can see number 2 that I talked about, reliable and resilient, and cybersecurity is part of that. So there's a lot of overlap as we talk about power systems, and we talk about power systems as a critical infrastructure. So obviously cybersecurity is important in that. So let's talk about smart distribution systems. So what else has changed as we look at the grid? So when we think of the distribution system, that's kind of from the substation down to your house. So you'll see a yard that has some switches in it, some transformers, and then it comes down to your house or industry. And so traditionally, what happened was we had generation, transmission, and distribution were all owned by one monopoly and controlled by one monopoly, right? So you knew all of your data and you had that. You only had one flow in the distribution line. All the roads were one way from the substation down to your house. It was one-way traffic. We had a little bit of information. We didn't have much information on the distribution system. All of it was in the transmission system and the power plants. And you were always connected. You always wanted to be connected. And but now we have distributed resources. You can have solar cells on your house. You can have their windmills on 195 between here and Spokane that are owned by a company and purchased by Avista. We have power electronics. We have batteries. We're talking more about electric vehicles. We have all the advanced metering and monitoring that was mentioned earlier. And now we actually talk about either being connected or separate. And there are lots of different aspects of this, but cybersecurity is an important part of the changes in this grid. So when we talk about the power system is the ultimate 24/7 manufacturing environment, right? Now, I'm a power engineer, so of course I feel that way. But at every second, you have to balance generation, load, and losses, okay? It's a balance. And if it gets out of whack, you can have issues and cause outages locally or even cause blackouts. So you're always balancing, and people are turning lights on and off. Things are happening during the day, changes. Lots of, what do we see when we see that? It's an industrial control system, basically with lots of different inputs that we have. And from all that, that's where our cybersecurity comes in. Because you can only do this if you have data, the right data. And if someone knows what data you need, they also know how to change that data to maybe get a different response or to cause a problem in what you're doing. So when we look at the power grid, is that industrial control system. So we actually can talk about distribution systems a little bit differently today than we could even say 5 years ago. Traditionally, we had the larger power system, and then we could have the distribution system where we have distributed energy resources, solar, wind, electric vehicles, and then the power now goes both ways. We see it going both ways. So we've now taken our one-way streets and we tell them we can go both ways. Sometimes though, in this case, it has to be interconnected. But the other opportunity is you could be a microgrid that separates, that has enough controls, generation to be able to support those loads. And you can also have, in the case of in the world, in rural areas, you actually can have the case where the grid, if I look at parts of Africa or India, they don't have the power lines there. So in order to have power, they create a grid, a microgrid locally. And the one we're doing in India, they use solar and they use biodigesters of animal manure to create energy for there, so they can have lights. They use LED lights so they can have lights. And again, that's something we can talk more about. So the microgrid and the microgrid can be, I've talked about India, but in the US, the microgrid can be a lot of different parts. It can be basically, it can be just, you can have a single customer that has a generator that is a backup. So that customer, just when the grid is not connected, it can run its power. You can also have a couple buildings and a generator that are doing that, up into the fact where you can even have bigger and bigger, where you can have microgrids. And this is from the Department of Energy. It talks a little bit about microgrids if you're interested in learning more. So as we talk about this, as we look at the evolution of power grid infrastructure, early on, there was the grid, there was controls, and there were computational resources. And what we're seeing today is those three circles are merging on top of each other. And what is at the heart of that is cybersecurity. Because of those interactions, cybersecurity is at the heart of that. And it's great time to be in cybersecurity. There are lots of different opportunities in the power grid space, whether it's in the Department of Defense, in industry, and there's just great opportunities to understand cyber and understand this domain of power systems. So if there are opportunities for you to learn more about power systems as a computer scientist, I'd encourage you to do that. And as power systems folks, encourage you to learn more about cybersecurity, because there's a lot of opportunities in the future. So industrial control system and cybersecurity. What makes this so complex? We've got solar, we've got wind. This is a picture of Palouse. These are a picture of battery and solar cells up in Avista. These are some electric vehicles up in Sonoma County near Everett. We've got utilities, all different types of utilities. We've got investor-owned utilities. We've got public power. We've got cooperatives that are all different types. We've got independent power producers, people that have built large solar farms to sell power to utilities. We've got people that are aggregators. They want to get all the people with electric vehicles and say, I can charge or discharge and make you money for your car with what your car is. We have lots of new sensors and new data that we have. And then what we have is called prosumers, where customers now aren't just customers. We're not just receiving electricity. We may also have our own generation on our solar cells on our house. We might also have the ability to have a thermostat that the utility can control. So when it's really hot, they can use less energy in my house to help keep the lights on across the system. And in that case, I'm actually a prosumer. I'm working with the utility on things I can and can't do. So with that, any questions on kind of what I talked about? Yes.
First thing is the observation that maybe you could add to. When you showed the slide of the United States in 2011 and 2017, build up of the infrastructure, it was interesting that Texas that just had the power outage. There was no real change there.
Yeah. So yes, and to be honest, a lot of this particular slide, let me go back to it. A lot of this, let me back up, and that's a very good point. As many of you may know, there are actually 3 grids in the United States, in the 48, lower 48. That there's the Eastern Interconnect, you can see this color. There's the Western Interconnect, and then there's Texas. And a lot of this happened because in 2009, there were recovery funds, and a lot of money was given to utilities to add infrastructure because it was helping with jobs and doing all that. So a lot of these came in. And so, yes, Texas didn't get a whole, I mean, on par with the other areas, Texas did not get as much of that. So yes, but that's a very good point. I should have brought up is the fact that there are 3 different grids too. Thank you. Yes.
So we'll look at African countries where power seems to be shared, distributed in one location for a day and a half, and then to another location. Is the problem that there's not enough generation, or is it more of a control system of what countries like that need to do?
So the big issue in those countries is generation and also power lines to those areas. And that's why, so this village that we have has a power line to it, but it would have electricity 2 to 3 hours a day. And so by adding the local microgrid, they can look at having it probably closer to 12 to 14. And as they add more things, even more than that. So the problem is there's not enough generation to go around. And if you think about generation plants, it takes a while to build those. And then, and then you've got to have the power line, you got to have electrical highways to get them to there. And many of those aren't built. And so basically a microgrid is like, instead of having a phone with a landline that some of us grew up with, they went right to the cell phone in parts of Africa. And the same thing with the grid. Instead of being connected, they're figuring out ways, but they still in their microgrid have to maintain this. And if things, and that's why they use LEDs and use different lower cell phone charging is a big issue in parts of Africa. People walk 5 miles to charge their cell phone. So if you can set up a charging station in a village or locally, it can be a real help to farmers because they use SMS to sell their crops and things like that. So even, but the issue is having enough generation to balance the loads as more and more people have loads.
I think what you're saying is generation is the key issue. But if they had more interconnectivity, they could redistribute power, it's not being used in one place to another.
Well, the challenge is more and more people get on the grid, you have to have more and more generation. And so, so you have to, that generation instead of having brownouts where people don't have power or blackouts, they rotate the power to different areas so different people can have it right now. But if they can build more generation, or if they can get local generation or batteries that they could charge, and then from the solar, then they can use those at night to have lights and things like that. Okay? Yes?
Over the past 10 years or whatever, power companies have made a push to offer more efficient platforms. How impactful are high efficient lighting?
So it can be a very big deal. So most of the lights in Africa are LED lights, where they may be just 1 or 2 watts to get what we would get 60 or 100 watts. And it's not the one house, it's when you put all of those together. It's not the one light bulb in your house. So it's really the cumulative effect. It's also when we have energy efficient appliances. So back about maybe 20 or 30 years ago, Tennessee Valley Authority offered $100 for you to buy a new freezer, because the freezers, the old big freezers, were energy hogs. And by buying enough of those, they delayed by 10 years a power plant they were going to have to build. So it's not just the light bulb, it's the energy efficient. But the challenge is we have more energy efficient, but we have more devices now. We have more electronics, right? We have more things to charge. So, but our load growth is much smaller. For a while, it was like 7% annually. Now it's more in the 1 to 2. And of course, COVID threw that all out because any trends and things like that. But it really helps us decrease the decrease. And what's important is the peak, and making sure it's not necessarily the day-to-day, but it's in the winter or the summer when you have those big peaks, making sure you have enough energy. And especially as we look at trying to have a carbon neutral energy portfolio, trying to do that without coal and natural gas and trying to keep it reliable is very important. Yes. So can you say the first part again?
One of the things that I personally think about is data privacy and residential smart meters. Is that a topic that is as well?
Yes, that's a big topic. Actually, data, that's a big topic on data and what you're, basically privacy and how do you know what's happening in a house. And an example was about 20 years ago, one of the ways the Canadians would find pot farms was they would find houses that the number of kilowatts per square foot was sometimes 10 times what other houses would be, because of all the lights they were using to grow. And so privacy is a big issue. How do you balance that? Even some people don't want thermostat, because if your thermostat's controlled by the utility, what does that mean if you need it? So privacy is a big issue on how do you, and this is a big issue between different utilities. How do I share data in a way that helps you be able to operate your utility, but doesn't give you some kind of advantage, financial advantage in a market for me? And so there's a lot of work that's done in privacy, not just on smart meters, but also between different partners, and all those partners I was talking about at the end that are part of how do I get a financial advantage by having some kind of data about what's happening there. So privacy is also a big topic.